Hey guys, it's Landon Blake from topbyasurveyor.org, and this is a video we're going to do on geometry, and it's a video that we're doing. We're going to do 2 or 3 or maybe 4 videos that kind of gently introduce you guys to trigonometry. This is the first video in that set of videos. A lot of people hear trigonometry and they think, ooh, that sounds really scary. It's not. It's just a fancy word that means math with triangles, so don't get freaked out about it. But we're going to, in order to really understand trigonometry, you need to know some things about triangles and about right triangles. And so what we're going to do is we're going to teach you some things about triangles and right triangles and ratios and something called Pythagorean theorem. We're going to teach you guys that before we introduce you to trigonometry. So we're going to have 2 or 3 or 4 videos that kind of introduce you, get you ready for trigonometry. Then we'll teach you some actual trigonometry, the trigonometry you need to know to be a land surveyor at least. So in this video, I just want to talk to you a little bit about triangles. We can talk about what congruent and similar triangles are, and then talk about the sum of angles. Okay, so we're going to talk about what's a congruent triangle. That's not super important, but I want you to know what it is. Okay, then we're going to talk about similar triangles. That is important, so we'll talk about that for a little bit. And then we're going to talk about just some of the angles, some of the interior angles of a triangle. There's a rule there that we need to know. Okay. And then we're also going to talk about similar triangles and ratio of sides. Okay. And don't be worried if you don't know what that means, because I'm going to explain it. Okay, so let's go through these things one by one. So what's a congruent triangle? A congruent triangle is a triangle that has the same angles and length of sides as another triangle. Okay, that's just a fancy way of saying they're the same triangle. Okay, so let me just draw them over here. I'll try and draw 2 triangles as close as I can to each other. So if these 2 triangles have the same angles and their sides are the same length, then mathematicians say they're congruent. Okay, normal people would just say they're the same triangle, but mathematicians have a special word for it. It's called congruent. Okay, not that important for trigonometry. Okay, similar triangles are different than congruent triangles. They're a little bit different. Okay, so similar triangles have the same angles, but their sides are of different lengths. So I drew 2 different kinds of triangles here. Okay, this is a right triangle. Okay, so it has an angle here, this right triangle I drew of 60, 30, and 90, 60, 30, 90. Okay, but you can tell they're different size. This triangle down here is smaller. Okay, so they're not congruent because their sides are different lengths, but they are similar because they have the same angles. Okay, same thing over here. This triangle's got 140, angle of 140, 20, and 20. 140, 20, and 20, but again, the lower triangle is smaller. Its sides are shorter. Okay, so again, these aren't congruent, but they are similar because the angles are the same. So you could just say over here, similar, you could put in parentheses, angles are the same. Okay, 2 triangles are similar if they share the same angles, even if their sides are different. Okay, now I'm going to come back to that in the last one. This is really important. And similar triangles are what makes trigonometry so useful as a tool. Okay, so just a rule here about triangles. Okay, I'm going to talk about this sum of interior angles rule. Okay, what that means is anytime you add up the angles to the triangle, they're going to equal 180 degrees. Okay, if you get something besides 180 degrees, you don't have a triangle. Okay, so you can see in all these examples, my angles add up to 180 degrees. This rule is super handy. Surveyors use it a lot. We use it to check for what we call angular misclosure. Okay, I'm not going to talk about that in this video, but it's a really important rule of geometry that surveyors have to know. Okay. Another quick rule about triangles: if you have a triangle where one of the angles is 90, that's a special kind of triangle. It's called a right triangle, because this angle that's 90 degrees, we call that a right angle. Okay. And you're going to see that surveyors use right triangles all the time. Okay, so right triangles are very important for land surveyors. Okay, and trigonometry works really well with right triangles. Okay, so they're a special kind of triangle. Right triangles have some other properties that we'll talk about that are pretty handy. We'll do that in another video. Okay, so those are just a couple things to remember about triangles. The interior angles will always sum to 180 degrees, and an triangle with a 90-degree angle is a right triangle, and right triangles have what we call special properties. Okay. Now let me go back to this last thing here, come back to our list and go to our last thing, similar triangles and ratio of sides. So we talked about what a similar triangle is. Okay, so I'm going to draw a couple similar triangles here. I'm just going to use right triangles because they're a little easier. Okay, so we're going to say 90, 40, and 50. Okay. I'm going to make this a little bigger, sorry. Actually, that's probably 50 and 40. Okay. Okay, so I've got two triangles here with the same angles, so they're similar, 90, 50, and 40. Okay, but their sides are different lengths. Okay. So they're similar, but their sides are different lengths. Okay, now, I want to talk a little bit about ratios and how ratios work with similar triangles. Okay. So what I'm going to do is I'm going to label these sides. We're going to call this side A, side B, and side C. Okay, we're going to call it A1, B1, and C1. And C2, A2, and B2. Okay. If a triangle is similar, the ratio between the sides are going to be the same. Okay, so for our example, let me get rid of some angles here and just put up some, we're going to just put up some lengths of some sides so you guys can see how this works. Okay, so let's say on this triangle, I'm going to write it in a different color. Not blue though. Let's try green. Let's say this triangle, this side is 3, this side is 4, 3 units, 4 units, and 5 units. It's called a 3, 4, 5 triangle. Okay, and this triangle over here, this is 30, sorry. This is 40, and this is 50. Okay, now, if these triangles are similar, you notice I didn't give you this side B1, and I'm going to tell you why in a minute. If this triangle is similar, the ratios of the sides are similar. That means if you know the sides of one triangle, you can figure out the sides of the other triangle. Okay, so let me just give you an example. Okay, so these two sides, let's look at this side, A2 and B2. Okay, so A2, the ratio of A2 over B2, okay, that's called a ratio, A2 over B2, is equal to the ratio of A1 over B1. Okay. So if I know the relationship between these two sides, as long as these triangles are similar, I can figure out the length of any of the sides of the other triangle. If I have the length of one side, I can figure out the missing sides. Okay, so let's just do this math. Okay, so I'm going to write in the values here. Okay, so A2 is 4. Okay, and B2 is 3. Okay, so I've got 4 over 3. Okay, A1 I know is 40. Okay. I want to know what is B1. B1 is missing. Okay. All right, so what we're going to do is we're going to solve this equation, and then we're going to plug the numbers back in, and we'll solve for that missing side. Okay, so let's just go ahead and solve this equation. So I want to be able to get B1 by itself. I want to know what B1 is equal to. Okay, so what we're going to do, another rule in math, we know we can cross multiply, right? Okay, so A2 times B1 is going to be equal to B2 times A1. Okay, so let's write that over here. So A2, we're going to cross multiply, times B1 is equal to B2 times A1. Sorry, I'm making those exponents and they shouldn't be. Okay, now I'm trying to solve for B1 on this big triangle. I want to get it by itself. Okay, so you can see to get B1 by itself, we're just going to divide both sides by A2. Okay, these cancel. So we get B1 is equal to B2 times A1 divided by A2. Okay, so now we can plug that math in. Okay, so B1 is going to be equal to B2, okay, which is 3, times A2, which is 4, okay, divided by, I'm sorry, A1, which is 5. Nope, I messed up. A1, 40, sorry. Okay, divided by A2, which is 4. Okay, so 3 times 40 is 120, divided by 4 is 30. So our missing side is 30, right? Which makes sense. We know this triangle is 10 times as big as this triangle. So 3 times 10 is 30. Our answer checks. Okay. So again, what that tells us is if we know two triangles are similar, that means the relationship between the lengths of the sides are similar. We can express those relationships between the sides as ratios, and then we can solve for missing sides. Okay, let's do another example. Okay, I'm going to do another example. This time we're going to solve for 2 missing sides instead of 1. Okay. So I've got 2 triangles. We're going to do right triangles again. Okay, and we're going to say this is 8 units, 8 units. I'll have to figure out what that is here in a minute. Okay. And I'm going to give you the length of this side here. So hang on, let me get my calculator out and do that math because I don't know it in my head. Okay, sorry about that, guys. So this side we're missing here is 11.31. Okay. And I'm going to tell you these triangles are similar, so they have the same angles. Okay, now I'm going to give you one side here. I'm going to say this side right here is 800. Okay. Actually, I'm not going to do that because that would make it too easy. So let's say it's 950. Okay, 950. Now, we know the relationship. These are similar triangles, so the relationship between the sides or the ratios is the same. Okay, so if these two sides are equal in this triangle, these two sides are equal in this triangle because they're similar triangles. We don't even have to do any algebra. We already know this side is going to be 950. Because these sides are equal here, they're going to be equal here. Hey, now we need to figure out this missing side. Now, we could do that with Pythagorean theorem, but I haven't taught you guys that yet. We don't need to because we know we have 2 similar triangles here and we know the relationship. Okay, so what we know is we can put it over here. We say, okay, this side, 8, over this side, 11.31, okay, is equal to this side, 950, over the side we're missing, we're going to call it x. Okay. Now, we're going to cross multiply like we did before. Okay, so we're going to cross multiply. So we've got 8 times x is equal to 11.31 times 950. Okay, then we're going to divide both sides by 8 to get x by itself. These are going to cancel. We're going to get x equals this math right here. Okay, so let me go do that math real quick, because I'm not going to do it in my head. Okay, so we got that 11.31 times 950. Okay, and then we're going to divide that by 8. Okay, and our missing side here is going to be 1343.5. 0.50. We'll carry that out to the 100th. Okay? So again, because these triangles are similar, that means their sides have the same relationship or ratio. Okay? And so we can use ratios and cross multiplication to figure out the missing side. If we're given one side, we can figure out the other two sides if the triangles are similar. Okay, now, that's a handy tool if you ever have similar triangles. Okay, but it's really important as a basis for what we're going to learn in trigonometry. Okay, so and here's what I want you to remember. And we'll talk some more about this in our other videos, but here's the principle I want you to remember from this video. Okay, similar triangles. Remember, triangles with the same angles. Similar triangles have, let's say, share. Similar triangles share the relationship between their sides. Okay, what that means is if one side in the first triangle is twice as long as the next side in the first triangle, then that same side in the second triangle is going to be twice as long as the next side in the second triangle because they're similar. The ratio is the same between their sides. Okay, and we learned that we can express this relationship. We can express this as ratios and solve for missing sides. Okay. Okay, and the reason this is important is because what trigonometry does is it allows us to take an angle of some known value and get the ratio between the sides that form the angle. It's really, really powerful. Okay, and it's just all it is a computer program that runs on your calculator, does a bunch of little calculations, and it says for an angle of this given measure, 30 degrees, the relationship between the two sides is always, the two sides that form the angle is always this. Okay, and that applies for any triangle with an angle that has 30 degrees. And so then we can use that relationship, given the angle, here's the ratio between the two adjacent sides, we can use that rule of geometry to solve for all kinds of missing angles and missing sides in right triangles. Surveyors do that all the time. Okay, so that's why similar triangles are important, and that's why that ratio between sides is important. I feel like I didn't do a super good job of explaining this. So if I didn't, let me know in the comments or send me an email and I will do another video. I'll try and do a better job of explaining it. But just to review what we talked about in this video, we learned what congruent triangles are. They're just the same triangle, fancy way of saying that. We learned that similar triangles have angles that are the same, but their sides are different lengths. We talked about how the sum of the interior angles of a triangle always equals 180 degrees. And we showed you that similar triangles that have the same angles, their sides, even though their sides are different lengths, they will have the same ratio, the same relationship between the sides. And that's important because we can use that to solve for missing sides. And like I told you, when we get to trigonometry, you're going to see how given an angle, we can figure out what the ratio between two adjacent sides is. We can use that to solve for missing sides and angles. So there you go, guys. There's your first not so gentle, but intended to be gentle introduction to trigonometry. In the next video I do in this series, we're going to talk about some special properties of right triangles. We'll talk about Pythagorean's theorem and how you calculate the area of a right triangle. And then after that, we'll gently nudge you into understanding what a trigonomic function, what a trig function does, and how you can use trig functions to solve right triangle problems. Okay? Thanks for watching, guys. Appreciate it.